right, in this podcast, we're going to talk about what we refer to as Bohr diagrams. Now, you probably remember Bohr diagrams from middle school. This scientist named Bohr thought that electrons stayed in a circular orbit around the positive nucleus. He was able to predict the difference in energies between each energy level, which basically allowed us to predict the energies from emission spectrums for hydrogen, and understand that these distances between each ring are quantized. They're a specific amount, and that specific amount is also the same amount that we see on an emission spectrum when light's given off by the element. Okay, so what's an energy level? So an energy level is basically describing how far away from the nucleus the electrons are. And he found that there was a pattern to how many electrons could be in each energy level. So if you see over here on the side where we got the little chart, okay, so in the first ring or first energy level, we can only have 2 electrons. Second, we can have 8. Third, we can have 18. Fourth, 32. Fifth, 32. Everything past there, 32. At least that's where we are at this point. Okay, think there may be more, but that's where we are right now. Okay, now, how do you look at the periodic table and tell how many energy levels a element should have? Well, if you look on the periodic table, the row number, so rows go across, right? So if it's on like row 4, that means it should have 4 rings. It's going to have 4 energy levels. Okay, so for an example, let's look at the Bohr diagram for aluminum. Okay, so if I pulled up a periodic table and looked at where aluminum is. Okay, so here we see periodic table. There is aluminum right there. And if you'll notice, aluminum is on the 3rd row. That tells us that it's definitely going to have 3 rings. So, pardon the fact that I don't make perfect circles here. All right, so, and we also know that aluminum's atomic number is 13. So that means 13 protons, which for a neutral atom would also be 13 electrons. So we got 13 electrons we need to put in the Bohr model. So we've got 2 on the first ring, and then we got to put 8 on the second ring. All right, and that takes care of 10, and then we have 3 left, and they go on the 3rd ring. Bam, there's your Bohr diagram for aluminum. Okay, so where did the Bohr model fail? Well, the Bohr model works perfectly with hydrogen, but it doesn't explain any other elements. It basically breaks down whenever you start talking about multi-electron atoms, because it's a little more complex than just rings. So in order to actually do a Bohr diagram correctly, you have to know what is called electron configuration.